So welcome everyone to Achieving Extreme SOLIDWORKS Performance Modeling Methodology. How many people were in our first presentation earlier this week? That's not enough. I guess everybody else left for the day, I guess, right? My name is Josh Altergott. I'm a support manager with Computer-Aided Technology. We are a reseller of SOLIDWORKS out of the Midwest. Me and my counterpart Adrian here are located in our Chicago, Illinois office. Adrian, I'll let you introduce yourself.
Like Josh said, I'm Adrian. I'm Adrian Fanjoy. I'm the Technical Services Director for Computer-Aided Technology. And Josh and I have been doing this sort of testing for several years now, trying to put a quantifiable number to SOLIDWORKS performance. And not in an overall perspective, but specific topics or specific settings and how they affect your performance. Now, our first presentation, as many of you know, was hardware and the configuration of that hardware. That's great. This presentation is all about your modeling methodologies and what you can do in SOLIDWORKS to improve the performance of the tool as well. Now, our objective. You can read it up there, build a better understanding of what factors involved in SOLIDWORKS modeling methodology makes the most significant impact on performance. That was harder to write than you may think, but we got it up there. And that's exactly what we're trying to do, but more in a nutshell, you want the workstation to be faster than you. Because at that point, you're not waiting on it, and you're at your most productive, at least relative to your tool, right? I can't account for coffee breaks and water cooler talk and, you know, who won the Super Bowl, but to make the workstation faster than you. Now, we're going to talk today about the environment and the setup of our test. Make sure you guys understand exactly how we put this together so you can see the validity of the test and how everything works. Overview of the hardware needs, what we were required to use for this test, and examining the modeling methodology step by step, each topic that we went through and tested individually and what the results of those tests were. And then finally, where it all matters, why all this matters, and where it can be used most effectively.
All right, so the why of the presentation. We always wish we could have better performance. That's something that everybody's always looking for. And you know, through all the training classes that we've taken, one of the things that we've never been taught is proper modeling methodology. We've always been shown how the tools work and what we can do with those tools, but we've never been taught how to kind of bring all that together and come up with a proper modeling methodology. And the last thing is how do I maximize the return on my investment? You know, your company has put a lot of money into, you know, you and your hardware and everything else. So how do we maximize the return on all of that investment? All right, so the model that we work with for our testing, it was given to us by Racine Railroad Products, a customer of ours, and it was a fairly significant model. It has, 1,200 or 1,300 mates inside of the assembly. It's got just over 10,500 components in there. And overall folder size of this, we're looking at 1.92 gig and about 5,000 files. So there's a lot of data that they gave us to use for our testing.
Now the benchmark we used. In the past, we used a macro to do this, but in more recent years, we used our programming team from Inflow Technology, one of our sister companies, to build an API interface for us that allowed us to control the test better, gives us easier turnaround on those tests as well, so we can do one right after the other very, very simply and easily. But it also allowed for more flexibility in the test. Now we are able to do the test with or without the graphical manipulations, the panning and zooming and all that stuff, so we can test just pure calculative reactions to the software or to the changes that we've made. Also, it's much more stable than the macro, way more stable than the macro. Bob did a great job putting this thing together, and our results come out noticeably cleaner and easier to deal with. Okay? The best part about the API now, though, is and as we've been asked by many people in the presentations in the past, we can use this API with any modeling environment and with any model. We've changed it so that we can do any model, at least any model we've tried so far. So if you've got something that won't work on that, I'd love to see it. But that gives us a great deal of flexibility in testing just large assemblies, which is most of this data, all the way down to small assemblies to see what the impact is. And some of you have seen that from our test earlier in the week when we were dealing with hardware, and we were testing RAM along a variety of different assembly sizes, clock speed along a variety of different assembly sizes, thus allowing us to make or to gather results for a variety of different customers. So very important for us to have that flexibility.
All right, so the tests that we run with our SOLIDWORKS benchmark, we do a data set, copy and delete. It actually launches SOLIDWORKS, opens, goes through a series of rotation, modeling, rebuild, saves, and closing. What we're trying to do is simulate what you guys do on a day-to-day basis as realistically as possible. And if anybody's programmed with the API before, you know that this is not an easy task. It takes a lot in order to build this. So our benchmark where we're at, we're in the alpha stage of it, but it's we're working on adding some more functionality to it for next year's presentations.
So in determining the right hardware, what we were going to use in this, we basically went with our test from the hardware side of this endeavor and picked what we had for the optimal machine. What we've noticed, RAM's critical to everything in a SOLIDWORKS environment. It's going to, not having enough RAM is going to slow you down in every aspect of your day-to-day life. And every assembly has its own threshold for how much RAM that it needs. Again, that was covered in the last presentation very thoroughly. So 8 to 16 gig is a good start for almost everybody, okay? Very few assemblies go over the 16 gig mark. Processors, SOLIDWORKS uses 2 cores, except for rendering and simulation, of course. And then the OS can use up to 2 cores as well, okay? The hard drive, we use SSDs, or at least 10% faster. We've had it as high as 15, 16% faster in some of our testing, and we found that the mid-range graphics cards are the best option to allow us the flexibility to handle just about anything, but not overdoing it, costing us a lot of money for functionality that we're not going to be using. So this is the machine that we use. Our friends at Box Technology have been kind enough to loan us hardware for this type of testing for 3 or 4 years now. An i7, 4-core, 4.0 gigahertz clock speed, overclocked to 4.5. Okay? 32 gig of RAM, we had that because that's so I could test RAM. We actually would only need 16 for the tests we ran today. Solid state hard drive, and a mid-range NVIDIA graphics card. So that's the hardware we use for these tests.
And the test environment, what we went with for our test environment was the typical setup, what we normally see inside of people's machines when we go on site or we remote into their machines and look at them. We went with SOLIDWORKS 2015 SP0. That's what was available at the time we started our testing this year. Win 7 64-bit, obviously at this point in time. SOLIDWORKS options set for the default. Large assembly mode is the exception for that. We like to test large assembly mode on its own, and you'll see why a little bit later on. We start off with 8 gig of RAM, 4 cores, 17200 RPM hard drive, image quality set for optimal, a high level of detail in the models, meaning if it was downloaded from the internet, it's got every last feature, fillet, you name it on there. Large number of top-level mates. You saw that from the beginning slide. We had almost 1,300 mates in our assembly. And loading up the assembly fully resolved. So that was our typical test environment that we went with.
So each of the tests we run is focused on a specific single change. So we'll make one modeling change or one environmental change and see what the results are from the previous test. Get a baseline, and then we test. Only one thing at a time, so we can get some more specific answers, some more specific results for you. Okay, the results that we show you today are not going to be in any particular order. In years past, we've done things like the least effective to the most effective, but this year we're just kind of mixing it up a bit. So, is this one mine?
That one is yours, yeah.
I can't read the little black letters at the bottom.
You're getting old.
You're getting close to the edge. All right, so does the age of a file matter? 2014 versus 2015 in comparative or relative to the version that you're actually using to do the modeling. All right, what we have found, we tested this with the files not converted to the latest and greatest, and we found that even as few as one file not saved to the latest version can increase your open times, can increase your saves, your rebuild times, almost everything across the board, but those are the typical ones. This can be very detrimental to you. It can be very devastating to you. It gives you a lot of incentive to just use that conversion wizard, bring them up to the latest and greatest if you at all can. And we understand that some people in more complex environments with data management tools and vaults and things like that, a mechanism like that is not as palatable and not as easy to use. Come up with a way or a practice or a procedure in your company so that every time they come up, every time these files come up, we save them to the current version. Did you have a question, sir? Good point. The question is the 15% performance loss, is it relative to the number of components that are saved in the old version? So if I had a 100-part assembly and I had 15 components that were old, would that be a different result than if I had 30% old? And the answer is, I don't know. I don't know. We haven't tested that yet. And in fact, this is right up his alley. He should be testing it, and we should ask him why he's not.
No, what happens when files are in the older version like that, when SOLIDWORKS goes and opens them and it sees a file as an older version and it hasn't been updated, it actually goes through and does a full rebuild on that model when it opens it up. So that's where you're seeing a lot of the lag time at. So, one file or multiple files doesn't make a difference. I think it's going to be coming down to the complexity of those files as well. So the more complex the files are, the longer it's going to add in that loss of performance. So.
Now, the other thing that question reminded me of is what we didn't mention in the first part is that, hey, Lenny, can you take your badge off? Can you take your badge off? It's actually flashing me. It is. What it reminds me of, that question reminds me of, is the thing we missed in the beginning. Please ask questions as we go through the presentation. Don't hold them to the end or anything like that. If we can't answer it right away, we'll save it to the end or something like that. But we want this to be as dynamic as possible. So just fire them away, raise your hand, whatever it takes. I appreciate that very much. So, yes, we've shown an up to 15% loss in performance in our testing. Now, in support, working with customers and that sort of thing, kind of anecdotally, we've seen even more. I mean, this is a big deal in a lot of circumstances, so keep it in mind as you go forward in your modeling world. Oh, man, I might as well sit down.
Oh, you might as well sit down for this one? Yeah. So system options. How do we choose the right option? Overall, for our testing here, we changed 18 different options in the system, or 18 different settings in the system options. We don't include lightweight or large assembly mode. Those tests, they come later on in this. Most of the settings changed our items that are visually appealing. We find a lot of those in there. But there are some other ones that are just good for overall performance as well. Testing has shown changing these things, we can increase performance anywhere, once again, 3.5% all the way up to 16.5%. And we'll talk a little bit more about that as we go in. We have a range for a lot of these because we've tested different machines as well, or different environments.
One other thing that we did not mention, and I've seen a lot of people taking pictures of the screen. By all means, keep doing that. Whatever you want. We're here to share. But also, we will give you a link at the end of the presentation where you can download it. Give us a couple of days to get it up there, but you can download the whole presentation full force, so you'll get it as well.
Yeah. All right, so what we're looking at, general options. I generally uncheck Show Thumbnail Graphics inside of Windows Explorer. I get rid of the news feed and enable sounds. I'm looking for, once again, things that are going to speed up the performance, things that are going to take overhead when they're running. So, one of the things that we do want to leave checked that people always ask us about is the SOLIDWORKS customer experience. We do want to leave that one checked. When you look at the help for this, the logs are already created, so there is no harm in sending in the data. It shows up also inside the CAD admin dashboard, so you're able to go in and look at those as well later on. Yes, sir. Usually, if you uncheck that, it does require a reboot before it kicks out, before the thumbnails go away. So, yeah, good question though. I like that use of the light, by the way. That totally got my attention. Thank you. So, as far as the drawing options go, they added a few new options and removed some others that were performance related. One of those was show contents while dragging drawing view. I double checked this in 2015. It's unchecked essentially now at this point in time. So when you drag a drawing view, it doesn't show the content. So it shows that SOLIDWORKS is looking out for our performance in this case and leaving or taking certain settings out, but leaving the right option checked at the same time. Colors, we make sure the background appearance is set to playing. All others add to video load is what it amounts to more than anything else. So for sketches, we didn't change anything. Display selection. For that, I really recommend hit the help button and read what all these settings can do. A lot of options that use video card, and if the video card is undersized, it may affect your overall performance. And that's another good point to bring up with all of these different system options. If you're not sure of what you're getting inside of here, hit that help button in the corner there, and it will give you all of the information about that page of the system options that you're on and really help you figure out what each of those mean and what they're doing for you. Performance, I set off options to off as far as mate animation, smart mates. I set those to off typically, or to faster, and anything to indicate or prompt. Warning if set to prompt and you later dismiss this message though, it can change these settings. So if anybody's seen our other performance on our other presentation on dismissed error messages, if you set something to indicate or to prompt you and you get that dialog box that pops up when you open a file and you say don't show me this again, it will go in here and set this to be never or always at that point in time. Assemblies, use large assembly modes. We got more details in this presentation, and we'll go into that in a little bit. For external references, once again, I set items to prompt because I want to know what SOLIDWORKS is going to do before it actually goes ahead and does it. This way, it gives me the option to choose exactly what is going to happen with my system. I don't use search file locations except for short periods of time. If we move a bunch of files around on the server or something like that, I may set up a search file location for that, but I'm only going to do it for a short period of time until all the links get corrected and back to where they're going to be. If anybody looks into, Adrian can speak more about it as well, the recursive searching for files.
Yeah, the recursive searching for files will absolutely kill you if you're putting items in there in the external references list. The search mechanism that SOLIDWORKS uses is built to get a file into the system regardless. And to do that, it searches in a lot of places, and a lot of places, believe it or not, that don't actually exist. It makes them up as it goes through the search path that you set up. It makes up places to look and then tries. So avoid it at all costs. Yes, sir. It's a good question. The question is there any locations that would affect performance more so than others? Is that a good summary of the question? And there absolutely is. If you've put network locations in here, and generally that's what people do is put network locations in here, you're going to have to deal with that recursive searching algorithm as it goes across the network each time. Oh, okay. Yeah, templates and that sort of thing. Other items that you would reference, libraries and that sort of thing, yes, they will be slower over the network, but most of those things that we're talking about need to be on the network. It is a detriment that you're just going to have to live with, and it's natural. The network's always going to be slower than going off the local machine. You just want to limit that where it's practical and live with it where you have to.
Yes.
Were you in our last presentation? Okay, because we did cover that. Antivirus scanning does affect SOLIDWORKS performance. So turning off scanning for SOLIDWORKS files as it goes back and forth across the network on both the server and the client can improve performance. I believe the number there was somewhere in the 10 to 15% range.
Yeah.
And speed things up. You just got to make sure that you're scanning for everything coming into that network so that you catch viruses at the right spot. And make sure that you're only excluding SOLIDWORKS files, you're not turning off antivirus. Good?
All right. Very good. Thank you. So default templates. Make sure that the templates point to a valid template. If you notice my settings here, I pulled this straight out of my 2015 settings. I have 2014 loaded on my machine also because I do support. And of course, my default templates for 2015 point back to my 2014 templates. So look at those, check those options, make sure they're in a location that is valid and that there is a template out there. Setting the option for prompt when opening step, IGES, whatever type of files. We'll ask what template to use for each individual part that it's opening. So you may be sitting there, with an open and having to hit, yes, I want to use this template over and over again. So make sure if you use prompt, be careful what it's going to do for you. It can also help you a little bit in some ways, depending on how large the file is, gives the machine a little bit of time to catch up. Or you tell it to always use the templates as long as it's pointing to a valid location once again. File locations.
How many of these do you have?
I got a bunch.
Apparently.
File locations. We want to check and make sure all locations are valid once again. Clear out reference documents. We talked about that fairly well already. Feature manager, uncheck the use transparent file. Adds the video load. Plus, it's just harder to see at that point in time for me. Once again, spin box increments. Those, I think, are a personal or company preference. For all your view options, I set those to off. Zoom to fit should be off, but we needed it for testing, so we left that one on. Backup and recover, use it, please. Touch, once again, that's a personal preference. Whole Wizard, it's a personal or a company standard at that point in time. Same thing with File Explorer. And search, avoid options that say may slow SOLIDWORKS down. It's listed out right there. In the settings there, so be aware of that.
Yes, sir.
I don't know. I haven't really ever tested it that way.
It's going to be the same thing. It's going to work the same way. So yeah, I would use it with that as well. What I would do with backup and recover, more important than anything else, is to use it judiciously and not set it to like auto-save every 6 moves or something like that, because especially if you're using large assemblies, that can definitely be detrimental. We've actually had customers that had it set to do the auto-save so frequently that it wouldn't finish the save before it had to start again. So when that happens, you get caught up in a loop and your performance, well, quite literally goes to pot. It's just awful. So be very cognizant, especially the autosave feature, what's going to happen. And as far as the standard backup mechanism, backing up a version or 2 is good, but if you back up too much, you're just filling up your hard drive with garbage, and it's going to affect you later if you're not cleaning that out properly. So just make sure you're cognizant of what the settings are, and I would also recommend making sure they're, as best you can, consistent throughout your organization so everybody's got the same effect when it happens. Okay?
All right, so the last one in here, and like Adrian said, there's a lot of different things. This was a long section to go through, but it's important that you guys realize what it takes, to make sure your system is performing optimally. Go through each of these pages when a new release of SOLIDWORKS comes out, read through them, and figure out, what works and what doesn't work for you. So messages, errors, and warning, keep dismiss messages to a minimum. I say check in on this on a fairly regular basis. There are over 150 different dismiss messages that you can create. It's kind of hard to believe, but there is. So double check on all those. Like Adrian said, you'll be able to download this presentation, Discovering Dismissed Messages. That's another one you can download as well. It was given by some of our other techs earlier in the week.
Image quality. How many people have examined this setting in their system so far? All right. Perfect. So you're well aware of it. Now, how many people have been using SOLIDWORKS for more than 5 or 6 years? Okay. This is very important for you guys. Check your current templates, because you guys are the ones that have been using SOLIDWORKS for such a long time that you probably built your templates based on their defaults years and years ago. And their templates years and years ago, I think it was 2006 or 7,
Something like
that, where they made the change or something like that. Their image quality was jacked up to the other side of this by default, and if you had your template set up back then and haven't adjusted this setting for your template since then, all your parts are being built with this already set too high. Yes, sir?
I have noticed, especially in older versions, that when you're doing drawings, if you have this set low, you will start to lose complex features in your drawing display.
It absolutely can happen. He's saying if you have this set low in your drawings, you can lose complex features in the drawing. What you got to watch out for is relative size in that respect. The smaller the object is, the higher this image quality has to be set to accommodate curves, small features, or just to ensure that a curve is round rather than jagged in a drawing, especially when you're zoomed up in a detail view or something of that nature, right? So you do have to watch that. In some environments that we have folks that make very large assemblies, like a die assembly is the one that comes to mind for progressive die. And if they make very, very small parts with a progressive die, you can have that phenomena happen. You can have, when you zoom in on the small parts, they'll be all jagged or hexagons instead of round. And you need that image quality set higher. The key, though, is to set the image quality higher for the individual part and not for the assembly or the rest of the model, okay? In SOLIDWORKS case, that's why this is a document setting. It is not a system option. It's a document setting because every document has a different need. So if you're in an environment where you make very small parts and very large parts, you need a different template for each, okay? To make sure that you got all your bases covered with the proper performance that you need, okay? And I don't care how small the part is, please, God, don't put it in the red. This is an exponential adjustment. As you go across, it's almost linear until you get to the 90% mark. and then it goes up like a rocket, and you end up with a 300 or more % loss in performance. Now that's if you include modeling and the graphics manipulation together in a time-based study. If you look at just graphics, this can be a 10 or 20-fold difference in the number of frames per second that your graphics card can paint, thus giving you the jumping and the jaggedness when you're trying to rotate the model. It can be quite devastating, even on a single part, okay? So just please keep it out of the red or you're just going to lose your mind.
Good. All right. So RealView graphics and shadows, that's still you for some reason.
Okay. RealView graphics, I'm an old guy. When this came about, I was not impressed whatsoever. I just want to model and get my part out there. And so in my world, in my mind, it's not that important. But a lot of people love it, and upper management like it a lot. They love to see pretty things on the screen when they walk by, right? So it gives you a realistic appearance, but it takes a large amount of system resources to keep it active, especially on the graphics side. It makes a big impact on the quality of your graphics while those graphics are in motion, okay? The key thing to remember here is to use it when you need it. Don't use it when you don't. Turn it on and off. But also, if you have this set on for a lot of models and your image quality may be a problem as well, it depends. We have a macro that we can give you. Just let us know, give us a call, and we'll send you the macro, and it'll set those options off for an entire assembly, okay? When you set these, like image quality, when you set it off at the highest level, it will go down through the tree and turn it off for the parts. That's relatively new function. It'll turn it off for all the parts, but the sub-assemblies will be left on, okay? So the macro we have takes care of all of it for you for both RealView, shadows, and for image quality, okay? Removing RealView and shadows, up to 20%. Again, this is comparing SolidWorks with the calculative functions and the graphics manipulation as well. In this, it's a much greater impact if you look at just graphics and frames per second that the software is able to generate. Much greater difference. So keep that in mind.
All right. Now you went too far.
Go.
All right, there we go. Part and assembly details. So if it came from the internet, it must be okay, right? Yeah, we all know that's not true. So what we did for our assembly, you saw the overall size of that thing. We cleaned up just the cab and its related parts. The cab assembly itself, its starting point was 30 megabyte assembly, 600 plus megabyte folder. The end point was down to 12.74 meg. And just a little over 550 megabytes worth of components when we did a pack and go on it. So removing details does have a huge, jump in performance. We remove part details like extruded text. If you need it in there, don't put it in there for the top level assembly. You need it in there for the sub-assembly. Create a configuration of it. We create configurations to imported parts. We changed options on patterns like using geometry pattern. We removed items like transparency that weren't needed. And testing has shown that by removing these details, we can increase performance by up to 50%. So when you're getting files off the internet, when you're getting files from the customer, take the time to go through them, review those files before you use them. Because once you use it once, you're probably going to use it twice or 10 times, and you're just going to perpetuate the problem throughout your environment.
This is also one of those areas where your results are relative in many different perspectives. One is this, if you have just one part like this one in a cab for a train engine or train equipment, just one of these isn't going to make a big impact for your overall assembly as you're trying to work with it. You got so much else going on. But when you bring up just this sub-assembly and work with it, the relative difference between having these features in there and having them out is very, very dramatic because it's just all the impact is right there in that one subassembly. Does that make sense to everybody? Okay. Yes, sir.
There's a fairly new option to save an assembly opposite part. Did you look at any kind of performance change?
It's coming up in a few slides.
Yes. Yes.
File sizes where they started, like 30 megabytes was in 2015. They redid the file size thing.
This one, that file size was from 2014 on that one in particular, yes, sir.
All right. Now, has anyone noticed something that, has anyone noticed that all the questions have come from that one corner? Come on.
You guys can step up on your side over there.
You guys are the only ones that need help. That's what it is. It's just you. I don't know.
This one's yours.
Oh, this one's mine too?
Yeah.
Okay. So, how do flexible subassemblies affect your model? Well, one, they make it much easier to determine range of motion and how a mechanism is going to function. That's great. But what it also does is it adds mates to the top level. Any flexible subassembly, any part or mechanism that's involved in that, automatically gets its mates calculated at the top level, thus causing more processor time and more effort to get the assembly rebuilt. Makes a big difference. And all you have to do to avoid it, just turn them off. Turn them on when you need them, use it, take the performance hit, but when you don't need it, just turn it off and get that performance boost. 13.5% is one of the smaller numbers in the studies that we've done or the results we've shown you today, but it's still 13.5%. It's a big number when you're trying to get through your day-to-day activity. It's actually, I'm assuming all of you only work 8 hours a day, right? Right? So it's a full hour of your day right there, all right?
We had a question from this side of the room, Adrian.
Woohoo! It's such a simple option to just turn on and off. That's what I would recommend. Don't worry about a config for it or anything. Just turn it off, and then when you need it, just click it back on.
Yeah, when the boss comes by and says, how does this whole thing move? You turn it on. When he leaves, you turn it off is what it amounts to. Yeah, or you tell him to use his imagination. That works out well as well.
Does everyone see where the red dot is right now? That's our boss, and it's his birthday. Everyone say happy birthday. There we go.
All right, so Defeature. This kind of falls into what's the best tools to simplify our assembly files. Defeature can be used on parts or assemblies. It has many different options. It is faster than manually modifying the parts, but you have less control over the results. We chose with our assembly, we were working with, once again, the cab assembly. We're removing internal components and ended up with a file that was a lot smaller in the long run than what we had, it ended up being larger than what we started off with. And I think the problem is we went too big with what we were trying to do. I went with the whole cab assembly. I just went through the default options with Defeature. So in our testing, it didn't increase performance, but we believe this to be because we went with the cab assembly and the default options, and we didn't have an intimate knowledge of the components like you guys will with your files that you're working with. So I recommend people try Defeature. Look at that, see what that can do for you.
All right. In our efforts to find ways of manipulating the model or portions of the model, we looked at SpeedPak as well. And this is one of our more effective tools. If you skip down to the bottom of the slide already, you know that. Okay? Can be created at the top level or any subassembly. You can choose faces or bodies that will be referenced. What we're looking for is things that we need referenced to the rest of the model, like mating points or something like that, or features that you want to dimension from or relate to in some other way. Getting those features up front and usable and everything else just be graphical data so we don't have to worry about the calculative portions of SOLIDWORks. It can make a gigantic difference, depending on how you use it and at what level of the assembly you're working with. This case was at the cab, I think we did.
Yes, once again, the cab. I worked with the cab for a lot of the areas of the testing because it was about a third of the model size. So we knew when we made changes to that, we were getting a good representative idea of what we could do to the whole assembly.
And that's exactly one of the aspects where you would want to use something like SpeedPak because it's a huge subassembly, and you've probably got a group working on that anyway, and all you need to do is have it there so when you're running a pipe or a cable harness from one side to the other, you don't run into it. You don't take up its space. So it's a perfect example of where this would be used effectively. What's our timing?
We're starting to get tight.
Okay.
So once again, what are the best tools to simplify the part? Somebody had asked about save as part. When we choose to save as part, there are 3 different options. There's exterior faces, exterior components, or all components. And we ran it on all three options here. When we did the exterior faces, it was our second best option. It increased performance by 21 to 55%. If we went with...
I'm sorry, we had a couple of questions.
Okay. Yeah.
What will happen with a SpeedPak subassembly if you try to step out the whole thing to get data to a customer?
It's a configuration, so my recommendation would be switch it back to the regular version, then do your output. I haven't tried it, but my guess would be it'd be not good. So.
Yes, miss. Yes, it is.
Yeah. So.
Anyone else I missed? I apologize. It's a big room. I can't see.
So let's see. Next one that we had here, saving out as exterior components. What we ended up with for this one here, this was our best option. It had a performance increase of anywhere from 26 to 60%. The last one that we had here was saving out all components. Everybody thinks that when you do save as part, you do all components, everything's going to be faster for you at that point in time. No, a lot larger file size. Overall, it was a performance decrease of up to 95%. So try these out. Check each option, save it out, see what the file size is, open it up, see how it looks as far as performance goes, how does it spin, rotate, all of that. Make sure it's going to be beneficial to you.
If you're working across the network without a PDM system, the absolute last thing you want to do is anything that makes the file size bigger, because that makes your opens, your saves, everything take longer. Everything, but the opens and saves a great deal longer. Is that mine?
That's you.
Yeah, large assembly mode, one of our favorites. How many people here don't use large assembly mode because you think it doesn't work? Okay.
Denny, did you raise your hand? Denny raised his hand for not using large assembly mode. He should know better. Oh, well, there you go.
Oh, yeah. Just get picky about it. Thanks, Denny. So, large assembly mode, it does work. When it first got introduced years ago, it didn't. But they fixed that since then. A lot of times when large assembly doesn't seem to work for you, what we have found is dismissed error messages that you've dismissed is the culprit. You're not getting the warnings that you should be getting to let you know that the information that they need for the pulling up the models isn't there or isn't available or is not in the right form at the time. So this has the greatest impact of performance. Our benchmarks showed from 58 to as much as 81% improvement in benchmark time. That's a big deal. You got to love that. That changes your whole world. It utilizes lightweight mode, but then it sets several other options as well. Level of detail is one of them to make the graphics a little easier to deal with for the graphics card. But all of that is an effort, especially for large assemblies, to get that data up to you as quickly as possible and lets you focus on the area of the model that you need to focus on at the time, resolve just those components, and get to work. You still have everything else out there, you still have everything you need, but you're able to get your job done with the resolved data that you need to have. Yes, sir. It affects open, save, believe it or not, close. After you've saved and you just hit go away SolidWorks, in a large assembly, sometimes it doesn't actually go away for a couple of minutes. But it affects that. It affects graphics performance, how fast the models can move, how many frames per second you can get. It affects that dramatically. It affects rebuild times astronomically. Most of our benefit came from rebuild time. Yes, sir.
How will this work with if you're given a file from another program like ProE? The first time you open it, you go in and have the same, or do you have to go through and set it up in SolidWorks after opening it and saving it out?
You have to?
Don't know, try it?
Yeah, try it.
Let us know what you come up with. We'll tell everybody about it and tell them we thought of it.
We'll be glad to steal your idea.
Yeah. It's an interesting thought, though.
All right.
So, what we want to do is look at a couple of optimals. Without large assembly, is this yours?
This is mine.
Go.
All right. See, you can't read. Optimal without large assembly mode. So, we changed all these different settings that we had out here, and we want to see, what is the optimal. And we did with and without large assembly mode just because large assembly mode does have such a big impact. So for our optimal file set, we changed all of our system options to optimal. We fixed the assembly details just for the cab once again. We saved the cab as a part file because we saw that was a huge benefit in savings. We turned RealView, shadows, we set those to off. We set our image quality to 25%. By the way, setting image quality to a lower scale also cuts down file size as well. Flexible sub-assemblies, we set those to resolve. That cleaned up a lot of our mates as well at that point in time, removed a lot of our top-level mates. And what we end up with is overall increase in performance, anywhere from 31.5% to 65%. So when we combine everything together, we aren't adding each one of those up. There is a cumulative effect in there, and like we say, anywhere from 31.5% to 65%, which is pretty good, right? So what happens when we go with large assembly mode? We turn that large assembly mode. We leave everything else for the optimal file set turned on. What do we end up with there? Anywhere from 75 to 90% performance gain. Should make everybody's day a little bit easier at that point in time, right?
Don't tell your boss that you turned it on and then hang out and watch movies. It'd be fun. So where it all matters, okay? As you can imagine, the more powerful your hardware, the less impact these things have. The less powerful, the more impact it's going to have. It's just the way it works. It's natural, right? So if you got 8 gigabytes or less, this is going to be a huge deal for you. I'd recommend just going and buying the RAM, all right? The processor, single core or low gigahertz, even dual core, this would be a gigantic difference, these methodologies would. Hard drives, if you're not using SSDs, you need to, but if you're not using them, this makes a stronger, more noticeable impact. And if your graphics are low-end or unsupported, well, you got bigger problems then because you're going to have crashing and instability from a non-supported graphics card, okay? But the best thing about all of it, can anybody think what is the common thread for all of these different items we showed you today? Did you do that?
No,
it just does it on a timer.
Yeah.
They're all free. They're all free. Nothing we showed you today do you have to pay for. You have to figure out how to get it done, how to get everyone else in your company to use the same techniques, but it's free. You don't have to go to IT to get a budget. You don't have to go to your boss to get them to agree to it. You just get to do it. So there's no reason not to at least try, right? Yeah, exactly. If you don't do it, you're costing money. It's a good point. Good question. Did we test drawings and drawing views with flexible subassemblies? It's kind of wrapped into the benchmark. We didn't specifically draw that out as an impact, but it is part of the overall impact. We did do drawing manipulation as part of it, and creating views and detailed views. So that is part of the benefit. All right.
So hopefully you guys went to all these other presentations that our company gave. This is a list of all the presentations that CATI and Inflow has given over the course of SolidWorks World. We appreciate everybody coming to the last session of the day and seeing ours. If you want a copy of any or all of the presentations, if you go to that link down there at the bottom of the page, cati.com/SolidWorks World SWW 2015. You can change that, by the way, to 2014, 2013. Keep going way back. All of our presentations are up there for a long, long time ago. So, and once again, there's another larger version of that link. For more information, if you go out to our blog, we're putting stuff up about this stuff all the time. We also want to thank Box, who supplies our machines, and Racine Railroad, who also does give us the model to work with. So thank you guys, and we're open to questions if you have any.
Questions? Yes, sir.
Options for patterning. The biggest thing for patterning is geometry, is using the geometry pattern where you can. It's just an option in there when you're creating your pattern. If you look at the very bottom, it says options. There's a geometry pattern option in there. Check that, and that's what it does. It's basically just rebuilding the faces versus each individual feature. So.
There was actually a multi-body class yesterday that was talking about the features. If you have like a funky geometry on the face and all the features, say the cuts come from that funky geometry, if you flip and put the features first and then do the cut for the weird geometry after, it will change the rebuild time exponentially faster. Like from, say 5 minutes or 1 minute to 3 seconds.
Really?
Okay.
Yes, sir.
It really comes down to the design intent of the model as well, and what the question is, what's the best way to sketch? Is it create a complex sketch and a complex feature, or simple sketches? And it really comes down, like I say, to the design intent and what's going to happen to that model later on. How many changes are you going to make to that? What possible variations are you going to need to make with it and stuff? So it really comes down to, I think, a personal preference more than anything. I try and create kind of go middle of the road more than anything else. Yeah, it always is going to have an effect on file size. The more features you have in there, the larger the sketches, all of that is going to add to the overall load of the file. So, yeah.
Yes, sir. What he was saying is that bringing in an extremely complex sketch like a DXF of an entire circuit board really chokes down a model bad, at least in his experience.
And there is too. I mean, when you import certain DXF or DWG files, there is in the sketch settings or the settings for your sketches, there is it'll turn off the enable snapping and auto solve mode like automatically, because if that sketch is too large, it will kick that out to try and speed up the performance of it a little bit.
Sir, did you have a question?
We got one all the way up over here too.
Yes.
Yeah. Yeah, when you're downloading files from the internet, you know, every vendor is creating files in different CAD packages. Some of them do have SOLIDWORKS in there. Some strip out the data from it. Others don't. I mean, one of the ones that I found is like Allen Bradley motors. I mean, you get this assembly and it's got tons and tons of all these details and all these screws and all these internal components. Yeah, that's why you need to go in. Every vendor is going to be a little bit different. And you need to take out what information you don't need is what it amounts to. You know, go in there, delete the internal components, or I've even gone in if it's a, you know, it comes in as a dumb group of solids, you don't delete any solid bodies you don't need, or create extrudes over the top of other features to kind of combine everything into one solid body at that point in time. If you got a huge collection of surfaces, you need to figure out what to do with that. You got to try and heal that up to not have a bunch of surfaces. There's some other techniques that we could use to kind of clean those up. So.
Yes, sir. Feature lock on components you don't want to build?
I haven't tested that at this point in time. So something I haven't looked at. Okay. Yeah, I haven't played around with feature freeze at all. So. Yeah. McMaster is one of those. It's a crapshoot. Those files have been created over several years, and you know, we've known some of the guys out at McMaster who have worked at McMaster, and a lot of times they were hiring temporary employees and stuff. So I think guys were building parts to build up their resume. You know, so. You know, and check origins and stuff when you're bringing in files from outside sources and all that plays a factor into it for sure.
You can basically tell the age of a McMaster car part. The older they are, the more threads there are,
yeah.
the more work there are.
And I went through and I was actually looking to do a blog article not that long ago, and they were going to be kind of, you know, one of my things for downloading parts off the internet, and I thought they were going to be the ones that I could say is being a bad example. And when I went through and looked at some of the newer models they had, motor assemblies and things like that, some of the larger file sets, they're actually very clean. 1 or 2 or 3 solid bodies, you know, not a lot of extrusions and stuff. I'm like, wow, so they have gone through and cleaned up a lot. So, yeah.
Other questions?
Anybody just want to hang out in here and wait till they kick us out?
All right. Thank you so much for joining us today. We know it's the end of the conference and everyone's tired. Come see us again next year.